Okay, so for example number 5, we have f of x equals 1 over x. So then f of a is the same as f of 2, which is equal to 1 over 2. So if we want to find f prime of a, we're finding f prime of 2 equal to the limit as x approaches 2 of f of x, which is 1 over x, minus f of a, which is 1 over 2, all over x minus a, where a is 2. And then since this is fractions and fractions, we need to get a common denominator. So our common denominator will be 2x. So you're going to get 2 minus x all over 2x all over x minus 2. So then since we have a fraction and a fraction, we're going to multiply by the reciprocal of the denominator. So that will give you one singular fraction. So you would get that this is equal to the limit as x approaches 2 of 2 minus x all over 2x times x minus 2. Now, here's where the factoring and tricky become a little bit challenging. What we need to do is actually take out a GCF of a negative from the numerator, thus making this the limit as x approaches 2 of negative 1, making that a negative 2 and a positive x all over 2x times x minus 2. So then you can see if you rearranged that negative 2 plus x, it's really x minus 2, which will cancel with the x minus 2 in the denominator, leaving me with the limit as x approaches 2 of negative 1 over 2x. Now I can plug in my 2, and I get negative 1 over 2 times 2, or negative 1/4. So again, sometimes the algebra is just a little tricky. You got to look for pulling out your negatives. So this was number 5 from section 3.1, derivative of a function. Let's also look at the alternate form, and let's look at problem number 7, where we have a square root using the alternate form. So for problem number 7, we have that the f of x is equal to the square root of x plus 1. And then f of a is equal to the square root of 3 plus 1, where a is 3. So we get the square root of 4, or 2. So f of 3 is equal to 2. F of x is equal to the square root of x plus 1. So what we're going to do is plug in to find f prime of 3. So that equals the limit as x approaches 3 of the square root of x plus 1 minus 2 all over x minus 3. So that you have that f of x minus f of a all over x minus a. So now what we're going to do is clean this up algebraically. So anytime we have a square root on top and bottom, I am automatically thinking about the complex conjugate. So we're going to multiply by the square root of x plus 2 over the square root of x plus 1 plus 2, so that we get the limit as x approaches 3 of x plus 1 minus 4, because 2 times 2 is 4, negative times positive is a negative, all over x minus 3 times the square root of x plus 1 plus 2, So then that becomes the limit as x approaches 3 of x minus 3 all over x minus 3 times square root x plus 1 plus 2. So your x minus 3's cancel. And we get the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. So that gives the limit as x approaches 3 being plugged in. So you get 1 over the square root of 3 plus 1 plus 2, or 1 over the square root of 4 plus 2, or 1/4.